A massive volume of research just dropped, bringing a wave of data that directly alters our understanding of the physical world. I have processed this week's overwhelming dispatch of scientific papers and extracted the most important findings, so you can stay informed without reading the journals. Staying updated on this data is essential. It provides the information needed to navigate daily life and manage the challenges of the future. Consider your late-night snacking. New data shows that night owls often choose less nutritious foods and carry more belly fat, which leads to significantly higher metabolic risks. There is a potential dietary countermeasure. Recent evidence suggests tomatoes contain specific compounds that protect brain cells from damage. This diagram shows how scientists are weaponizing our immune system by turning macrophage membranes into nanodiscs. These discs bind to and physically disrupt fungal infections like Candida albicans, causing them to leak and die. Diagnostics are also becoming more tactile. A new robotic gripper uses flexible electrical sensors to identify bacteria by physical touch, distinguishing cell wall structures in milliseconds without the need for chemical stains. At the molecular level, researchers are developing self-building rings that assemble automatically. These structures are designed to improve targeted drug delivery and the creation of responsive, smart materials. Treatment is moving into the physical realm, using structural engineering to target and dismantle threats at the cellular level. We see similar upgrades in our communications hardware. To eliminate the lag of buffering video, optical networks are now moving toward speeds of 800 gigabits per second. This schematic shows exactly how that speed is possible. A new 200 gigabit per second photodetector uses an integrated rear lens structure to double the capacity of current optical modules. Materials are also adapting to extreme heat. Engineers have fabricated a 3D thermal cloak that guides heat around complex objects, making them invisible to infrared sensors while protecting their internal temperature. This visualization shows computer-guided electron beams warping flat nanofilms into 3D shapes. These virtual cathodes can create reversible domes in seconds, allowing for precise control over microscopic movement. This level of engineering even applies to sports. Looking at the panel geometry of the Trionda ball, wind tunnel data confirms it has a stable, predictable flight path due to how it transitions airflow. Our physical hardware is adapting to extreme conditions and high data demands faster than we realize.
Urgent, high-energy update on deep space and high-concept physics. First, astronomers reported the first-ever detection of a complex sugar molecule floating in interstellar space. In deep space, X-ray tracking of the G292.0 supernova remnant proves the explosion is expanding unevenly, creating a chaotic, asymmetrical burst pattern. This diagram maps out how physicists are emulating black hole energy extraction. By using electronic resonators to create synthetic rotation, they can amplify electromagnetic waves right in the lab. This crystal structure model shows the solution to a 30-year-old superconducting mystery. It proves that internal coupling between layers, not direct charge, is what controls the conductivity in YBCO materials. We even corrected a historical error. By analyzing these glowing trails, researchers found that fireflies are actually thousands of times dimmer than measurements from a century ago suggested. This chart maps exactly what happens when cornstarch droplets hit water. Depending on speed and concentration, they exhibit 5 distinct behaviors, from liquid lumps to stable, wrapped bubbles. These updates, from interstellar chemistry to the mechanics of a liquid impact, provide a more precise map of how matter behaves across every scale of the universe. While we map the cosmos, immediate Earth-scale changes are becoming more frequent and severe. An extreme heat dome in the western U.S. is pushing temperatures to 43 degrees Celsius. The human toll is evident in this extreme heat, while in Italy, falling river levels are allowing seawater to intrude 25 kilometers upstream. These events are linked by large-scale atmospheric shifts. For instance, we now know that conditions in the Indian Ocean directly trigger severe winter droughts in the Mediterranean, thousands of miles away. This interconnectedness shows that localized anomalies are symptoms of a massive, global system that is starting to break down. We are using new technology to monitor these crises. Machine learning is now calibrating biosensors to track toxins in freshwater more efficiently across different environments. In hazardous environments like this active volcanic vent, autonomous drones are now mapping corrosive gases. This allows us to predict eruptions without exposing people to the plumes. We also know that major earthquakes in Southeast Asia are causing land subsidence that last for decades, which means current sea level rise projections are likely underestimating the risk. Despite these scientific defense efforts, corporate accountability is lagging. Only 13% of major biodiversity pledges from influential companies meet basic standards for transparency. As the planet enters this period of instability, staying informed on real, hard science is our most effective tool for survival.